Los dejamos con Francisco Estrada, coordinador.
So now we have Dr. Francisco Estrada. He's the coordinator of research projects in UNAM. He is he has been a researcher in climate changes in the National University Institute for a while, and he's going to be explaining how these can be landed regarding investments and portfolios. Thank you. Thank you very much for your invitation to talk to you and be here.
Gracias. Perfecto. Bueno, entonces les voy a platicar.
So let me talk to you about the physical changes of climate change in Mexico. It is very often when we hear about climate change, we think of other places in the world, and it's an international kind of program, but we don't really have a notion of how this is directly impacting us. You might have been already having conversations with other more experienced colleagues that are reviewing climate risks and they're working on it, but it's always good to have a notion on how we're getting there and where we are. So I'm going to be talking first about the observed changes in the weather. This is not model future, this is what's happening. So what we have here is the average temperature of the area in Mexico in average meaning the country. This is not rather relevant for decision making because this is a very diverse country, but it does give us a notion of how the heating is going in our country. So we can see here different databases. We have NASA here, British and American databases from particularly the Administration of Atmosphere and Oceans. And what we see here, you might be familiar with this. This is a Harvard basket filter, just so we realize what are the trends under the highs. So one thing I want you to pay attention at is that the average temperature of the area of Mexico has increased over the global average. We're around 1.1, 1.2 degrees pre-industrial average. In Mexico, we are reaching 1.7 degrees over the pre-industrial times compared to 1.23, and this is what pertains to previous big early last century. And the quality of the data, it's complicated, of course, but in this time frame, this is 47 years, I believe, we see that the global temperature has increased around 1.9 degrees per century. That's, let's say, the rate. And in comparison, Mexico's rate has been increasing at 1 degree higher. So we expect this to happen in the future again. We can see the trust intervals, and this is not the only issue. The issue is that we have seen an increase over the global average. We're going to keep that trend, but the observed changes in the weather are rather unequal. This means that we're going to have different risks on different parts of the country. It's more like this is happening right now. So these are the trends in temperature. This is the trends of how the temperature has increased and how much it would increase in 100 years, every dot in this map. And we have gotten this in a 40-year span. So the overall trend in the country nears 2 degrees. We have some areas where the increase in temperature is much higher. We see some areas which is over 5 to 6 degrees per century. This is the rate. And in the south kind of country, we also see around a 5% increase. So we have rather different problems in different parts of the country. And we will see this even more in detail when it comes to rain. So the precipitation has increased in the last century, 2.9 millimeters per month per century. These might not be saying anything to you, but it's a lot. It's a very relevant increase. So the issue is not just the increase or decrease, but how it's distributed. And the space distribution that you can see here, these are the trends for the same period, but just in terms of rain. There's essentially regions in our country, north. I mean, I can show you in summer, and it's different if I show you winter or fall. But this looks a lot like the yearly pattern. what happens? The northern part of the country is dry and we have far more precipitation in the central and south part of the country. And this is not the only issue, but also the way it's raining. So let me elaborate on this. Well, a little further on. But I can mention another issue. It's that it's becoming more extreme. We're having longer drought periods and extreme events of rain with a higher magnitude as well. So you might have seen this already with David. I wasn't here early in the morning, but probably you've seen this. And it's very important to talk about attribution here. We can see an increase in temperature. We can see a change in the rain patterns, but why? Right? After we have changed, we always wonder why. And there are many reasons to find the why. We can see the black lines. This is the observed global temperature. And we can see the clouds, the different shades. It's what happens if we run the best scenarios for weather. What are the factor combinations where we can reproduce what we have observed? So we have here, for instance, if we are only looking at natural causes, natural factors, we will never be able to recreate the trend that we have seen since the 60s. If we see anthropogenic and natural factors, we can reproduce easily this trend. This is one of the ways we do this attribution. So another thing that we did here in this paper was statistics. These methods might be very familiar to you. It's basically econometrics, but we see that not only the concentration of greenhouse gases have shaped the trend, but there are specific events like First World War, Second World War, the Great Depression, and other changes in the crop production that occurred in the 90s and the Montreal Protocol. They have left footprints in the global climate. When we were writing this paper, it definitely shocked us because it's not only the fact that you can see the trend on a long term, but the things and the global events that we can see that are at high scale leave a relevant footprint in the global temperature and the hemisphere temperatures. And the other thing, this is a global basis. In Mexico, we have also carried out these studies. And what we have seen is that this increase that we have seen at first comes from the anthropogenic factors. So we were able to break down these effects. So if we were only considering the greenhouse gases and not the atmospheric aerosols that are also man-made, we would not have reached 1.7 degrees. It would have been 70% more. Other atmospheric pollutants have the opposite effect to heating, which means cooling. And this has been compensating a lot on the heating. And if somebody is wondering about the solar side of the heating, it's about a 6% of the overall increase of what we have been observing, is 1.7 degrees. So what has happened with extreme events? So you can see here the change of risk regarding extreme temperatures. So the hottest days in the year, what is the change in the likelihood of this occurring? In the first part, we can see what was observed without any sort of breakdowns. These are the statistical likelihoods and probabilities in the period 1961-1990. These are the change in probabilities from the rainiest day of the year, the hardest precipitations of the year. What we see here, I don't think we can see it great, but the red areas, which is most of our country, the probabilities have increased 5 times, about 5 times, the heat extreme events. And in this rain map, in change in the risk of extreme rain, we can see how it doubled in the same period, 1961 to date. And we can, this is how we break down the signals of the events. This is the attribution, and we can do the same with the extreme events. These are the man-made changes. What are corresponding to man-made? It's this, and natural is this. Green, it's essentially zero contribution. And one thing I want you to pay attention to is that if you add up these two, you won't get this. There is a relevant interaction between the man-made and the natural sites. So it is more, it's beyond proportional. So we have the greenhouse effects, and we won't have a linear increase only by the man-made side. So on this side, considering these changes and the likelihood of the changes in the risks, how much of the overall population has faced the higher risks due to increased temperatures. So if we bring together the population maps and these risk assessments, we see that about 94% of the worldwide population has an increased risk for derived from increased temperature, and this is mostly man-made. So let's switch maps. Let's see how more exposed or how more vulnerable is the GDP in the planet due to extreme temperatures or rain patterns. So compared to the period of 6190, the overall GDP is more vulnerable to extreme risk, and around 77% it's man-made. If we see this map over here, we see the extreme heat, extreme rainfall. You have population over here and GDP. And the circles, the largest circles, it's more people or more GDP. And the color means how dramatic this statistical change has been. So if we see this, particularly Mexico, some cities in Mexico are in rather a vulnerable position, and we can see some pinpoints where these relevant and dangerous events have occurred. So what is in for us in the future? These are the newest models, the best physics applied to the IPCC scenarios. This is the average yearly temperature from the most dangerous scenario. It's SSSP 126 and the SSSP 858, which is the most dangerous one. And we have one that it's essentially what happens if we do not change any policies. It's the SSP 370. And then we have the ones that are rather inclined to policies, the 245 and 126. We have a slight mistranslation here with between the ISS scenarios and the SSP, the INGFS scenarios and the IPCC, because we are far more studies done with the IPCC scenarios, so we can get a better grasp when we get to map this. So the current policies, it's one that the IPCC is not really using in the sixth assessment report, but we see from 2.6, 4.7, 7, 8.9. This is a measurement in terms of, it's the watts per square meter that's going to change the radiation strength. It's kind of a technical thing, but it's essentially the biggest number, the biggest change in the climate. The current policies of the NGFS, it's are SP6, 6 watts per square meter, and it should be around here in the middle. That would be the current policies. 2.5, it's very like the nationally determined contributions, the INGFS, the NDCs. But everything that is orderly and disorderly transitions under 1 or 2 degrees, there are around 1.26, just about. And this is the temperature for Mexico in the worst case scenarios. In some of the more scenarios more inclined to change, this is sort of the average. And another thing I want you to pay attention to is, why is this relevant to just see all the way to 2050 and not only the 5 years? So these changes between scenarios are not really showing before mid-century or before. So if I'm gonna head down this path or this other one and I consider a short term, I won't be able to see the difference. The transitional risks are gonna be more evident, and we will be hearing about this tomorrow, than the physical risks. So we need to consider a bigger time frame, and this is rainfall all across Mexico. It's a hundred of thousands of running of the model. So the worst case scenarios, we would have an average of 15 to 20% reduction in rainfall in our country. If we were heading towards the Paris Agreement side, we would have a slower reduction. There is a lot of uncertainty. If you place this in a map, we have very different risk implications for different parts of the country. And we will discuss this in a minute. But another point that David was already talking about is that what happens in our climate, it's directly connected to the economy in the planet, right? So the developments that are focused on fossil fuels imply rather radical changes, essentially. So what do we hear about the outputs of the models? That for Mexico, we can expect drier and hotter conditions for this century. So if you see it in the map, this is rather varied. And now we'll delve into this chart, but you can see the diversity if we see all of those scenarios by state. The rainfall and temperature change a lot. And another thing that we were hearing is that it's not only rainfall and temperature, the ones that are changing, but also the extreme events associated to these variables are also changing. So for instance, one of the things that we perceive that might happen is that maybe the number of days with rainfall, very rainy with rather strong rain, are going to be less. But the amount of rainfall that we're getting on the rainiest day of the year, that's going to increase. So this implies some issues for the administration, for water administration. So you can see the changes in yearly rainfall. This is for the end of the century. We have a document, and we also have a report that was financed by Pinoma. You can give us your email address and I can share this to you. This is for mid-century and the end of the century, this information. We have some places under the most severe conditions. You can see RCP 8.8, 126. How would the rainfall would change for the different across different states? The higher the emissions, the less reduction in rainfall. And we have some states like Campeche or Yucatan where they're going to be drier. And the increase in temperature, you can see the changes that are expected for these different emission scenarios, with the harsher ones having an increase of over 5 degrees in places like Sonora or Coahuila. If we see a mid-century perspective, these increases go around 2.6 degrees, just about. And this is what I just mentioned. We are expecting that the rain patterns will be more extreme, particularly during in more drastic emission scenarios. So, for instance, Colima, by the end of the century, they would have 20 dry days in a row, consecutive, more than what they have today. And you can see this across different states. And this is how rainfall would increase in the rainiest day of the year. So this is in millimeters. 8 millimeters, it might not sound as much, but if you already have a rainfall of 100 millimeters and you add an additional 8, and that is a lot. Now, regarding the more tangible risks, what happens in the economy, what happens across different sectors. How much does climate change cost? We did this in ONAM, and the Libre University of Amsterdam, and these are the yearly impacts under these scenarios. This is an economic development and severe climate scenarios. What you can see is $1 billion lost. So one thing that I want you to pay attention to is that the red dots that start popping up means cities. Essentially, we're going to have so many problems there. Of course, agriculture is vulnerable, but cities, sometimes we forget. Due to different reasons, these are one of the most vulnerable places to climate change. So, for instance, specifically for Mexico, how much does it cost? If you get the current value of those years and you compare this, just to understand this in terms of the current GDP, this would translate into a loss of half of a GDP of Mexico and 5 times the total current GDP. That's the size of the issue. Another thing that we can see in these maps is that in the second part of the century, most of Mexico would have yearly losses that equal or are over 5% of the GDP. And then again, we have very diverse risks across the different parts of the country. These are all of the states, and this is how much they would lose in billion of dollars per year. So we have Mexico City here, Mexico State, Jalisco. There are some states that are rather highlighted and that will receive the worst side of this economic impact, and we'll talk about why. A relevant thing about cities is that we have a lot of people. So on a global basis, we have over 50% of the population in cities. And in cities is where we can see a production of about 80% of the GDP. So what happens in the cities does not stay in the city. They would affect all of the region within the country itself, and the planet. So in this study that we carried out, it was the very first one to see what happens if we bring together two issues. And this is very important. When you make a city, you go from a rather rural area to an urban area. You have concrete, you have buildings instead of trees. It's a change in balance on a local basis and a small climate change area. This is the heat island, and it can be just as bad in the city, which is a limited area. The change in temperature could be in the same magnitude then with the worst scenarios of climate change on a global basis. So for instance, this is Mexico City, right? This is Mexico City, and just picture it because it comes with the scenario. So if you see the very first spot, this is the heat island of Mexico City. There are some townships like Venustiano Carranza in the city that have an increase of 4.5 to 5 degrees due to local climate change. If we add maybe 4 or 5 degrees, we are in danger. There are many things that can be done locally. We can discuss this later to reduce this heat island. But in this paper that we can see, it's on a global basis. What happens if we ignore the heat island? So we make the calculations of climate change, and let's say that we have 1. That is what's costing. So what if we bring the heat island in every city? We would have to multiply it by 3 times 3. And this happens on a country level everywhere. And something else that we can see with this model is these are the risk measurements. We have some dates here. When will we be over at least $1 billion losses per year? So we see a map of when larger cities, for instance, Mexico City, Monterrey, and Guadalajara, they are crossing this threshold either in these next 10 years or the next 10 years. And in the areas surrounding, they're very close as well. This is due to climate change and local climate change. I already mentioned this. Okay. And agriculture as well. What are the impacts? What are the possibility that climate change actually changes the output likelihood in the country? Oh, all of these are linked to papers. So if somebody's interested, we can send you the paper. So we analyze 6 crops for the country, for every state. And these are the changes in the yields. Corn, rice, soy, sugar, by the end of the century. But we see in some states a reduction of 20 to 30 somewhat percent, for instance, the corn. And these are the costs of corn, rice, soy, and sugarcane and how they evolved in sorghum and how they evolved in the following years for different scenarios. I forgot to tell you this, but the cost of climate change, if we were basing ourselves in the Paris Agreement, you remember that I told you 0.5 or 5 times the Mexico's GDP, it would cost half. That's what we got to.
And there are many residual risks we should be considering when we think about adaptation and how to handle the risks. So the current value of losses for these 6 crops is of about $38 billion, twice the agricultural production of the total agricultural production of the country, not just the 6 crops. And this varies by state and by crop. This chart shows rice, sorghum, and wheat, and the current value for each crop. So once again, we have a highly heterogeneous issue. We need more knowledge at a more local scale than we're used to. Costs from floods and coastal flooding. Flood costs are very high in Mexico, but this will increase even more. One, because of climate change, but also because usually we put more people and more wealth in places where we should not be putting them. That is a silly issue, but highly persistent one. Currently, the annual damages expected per year is $7 billion. So that's how much the country loses every year. By 2080, because of population and exposure and climate change, economic costs by floods would go from $7 to $116 billion a year. For coastal floods, we are losing about $130 million by the end of the century. It would be $10 billion. Those are really drastic changes. And states with the highest risks due to floods like Tamaulipas, Veracruz, and San Luis Potosí will continue having the highest absolute risk levels. But the biggest changes in terms of risks can be found in the central part of the country. This is annual expected damage due to floods for 3 climate change scenarios. The current situation, if we maintain constant weather and we just made social and economic changes, and if the Paris Agreement was complied with, and the most severe global warming scenarios, and the same from coastal flooding for the same scenarios. And you can see that impacts are highly heterogeneous. Costs due to variation in electrical power and gas due to climate change. Depending on temperature rises, we will need more or less energy for cooling down, because for cooling we use electricity, for heating we use gas. And we have estimates by 2050, the increase in the power demand of the country would be about 4%, which is about 17 billion pesos. By 2100, power demand would be 12% higher cost at $69 billion. When we consider savings in gas compared to losses due to a higher power consumption, costs would be $1 billion 2020, 8,700,000,000 pesos 2050, and $43 million by 2100. Eliminating with the losses due to decreasing the use of gas. Increases in losses due to tropical storms. It comes from the climate analytics from NGFS. These charts compare costs per tropical storms. And if we look at 2050, this is the cost. Here we have the current, similar to RPC 6, and this is for orderly and disorderly transition, and this is very similar to RCP 2.6. So with the current policies, by 2050, losses will double, and by the end of the century, it will be 2.5 times as much as in 2015. And this is for the percentage changes in damages expected from severe hurricanes, one of those hurricanes that happen once a century. So these are you can see increases in damages are very similar. Then changes in labor productivity. This is another effect of climate change. And you can see under the current policies scenarios, by 2050, productivity will decrease 6.7% points under different models. By 2100, 12.3. And when we go and look at the individual states, in some places, the productivity may decrease 20, not 6 or 12, which means highly varied impacts. And population exposed to heat waves, that has a high cost in terms of healthcare, especially with the elderly. And that exerts a high pressure on the healthcare system. There will be a huge increase, and that depends on where we are. This is 2050 and 2100. Tabasco, the highest, 2050, between 25 and 40%. Additional people exposed to heat waves, and by the end of the century, it may go above 60%. Just an ad, but important. Everything is going to be to appear in this book. This is the status and perspectives of climate change in Mexico by UNAM and the UNAM's Atmosphere Sciences Institute. This is the work of over 100 investigators and researchers of climate change in the country, and it will be available during this month and early next year. And you can find more information in different reports that we are preparing for UNEP. Thank you very much.
¿Alguien tiene alguna pregunta para Francisco?
Questions for Francisco? Thank you very much for your talk. Your cost projections, what hypothesis do they consider? An increase of exposure because technological changes and huge advances in the industry, but also because of an increase in population, which also has an impact on economic factors such as inflation, etc., that could also impact these projections of losses by 2080, etc. And you showed us a chart of physical risks and transition risks. So considering those projections, what type of risks are you considering? This is my first question. And number two, how does this relate to the risk, the endemic risk? Have you studied this risk? Because I didn't see any connections in your presentation. Well, thank you very much for your questions. First, and let me go back. When we talk about the different scenarios, like RCP 8.5 is a scenario that cannot be reached unless you're talking of a highly globalized world depending a lot on fossil fuels. There is a whole history behind all these scenarios. They all start with thinking how the world is going to evolve between now and the year 2100, and technological changes really high, but it is based on fossil fuels. The point of these scenarios, these are self-consistent stories. For example, let's pick this scenario. In here, the world has done an important energy transformation going for renewable. The population is not so big, it's growing, but not so much. Like the worst case scenarios with the highest population are over here, but each scenario has characteristics of its own. Even literacy and illiteracy rates in every country, political regimes, there is a whole history for each scenario. Then we go into quantifiable methods and then we get this. It is very complicated to give an answer, but let's say this. This is a senonario of large economic growth, RCP 8.5, high technology, fast economic growth. Impacts are huge here, but also because population is growing and because their GDP is also increasing pretty fast. Your second question. I don't know of any works that have linked this with epidemics. It has taught us that this is not going to help us. Like some event, it's not going to help us with emissions. Emissions did go down for 1 or 2 years, but after the pandemic, we tried to regain the lost economic growth and they started burning whatever. Others used it for transition. But impact on emissions is very small, cannot be seen. When you go to concentrations rather than emissions, you cannot really differentiate. However, it does teach us that, and I'm talking globally, it means that as a society, we are not so separate from nature and we are still highly vulnerable. And this is one single risk. But what happens when you have health issues, when you have trouble in producing food, when you have heat waves, when you have other health issues? And what happens when all those risks happen at the same time and are correlated? Then they become much more difficult to manage. So my point of view is that the pandemic's lesson is exactly a grounding one that teaches us about climate change and how problematic handling these issues can be when they happen simultaneously. Transition risks, I am pretty sure that David is going to talk about them in more detail tomorrow, but just think this, there will be an increase in power consumption, and that is related to emissions because this power must come from somewhere. So many of these risks will start feeding back each other. Okay, we'll just ask you to go as fast, to be brief and fast as possible. I have two questions and they are different. The first question may be basic, and this is regarding these scenarios. For example, temperature increase, if you want to mention precipitation as well, it's okay. But what indicators do you consider for estimating costs? You say temperature increases, this is a cost, but what do you take into consideration? Number two, going back to my colleague's question regarding the pandemics in 2020, because of recession, the emission and concentration of CO2 equivalents went down, and why the spike in the following year, it practically doubled. Let me begin with the second question because it's a shorter answer. One thing is concentration and a different thing are emissions. Emissions went down. Concentrations, when you send 1 ton of CO2 to the atmosphere, it will remain there between 50 and 300 years. So it's really hard to have a decrease. And second, integrated models, it depends on the model, but generally models have damage functions integrating everything you find in literature, like agriculture or energy sector, and they put it all in a function of damages that is validated, or that's on the one hand, but on the other hand, you have studies by sector, like, for example, agriculture. Those are biophysical models simulating plant growth, changes in yields, etc.
Hola, gracias. Oye, comentabas sobre los
Thank you.
distintos escenarios integrados.
You were
¿Hay
talking about
escenarios
the
y
scenarios.
algunos tipos de riesgo por clasificación más
There
general
are
que
some
permanezcan
risks
constantes, principalmente
that
investigados, que se hayan
stay
podido
as
identificar como los de mayor impacto
constants that have been identified as the
relacionados con el cambio
highest
climático?
impact ones related to climate change? For example, socioeconomical stories behind scenarios have different risk levels each. For example, some assume that the planet will maintain high inequality levels, or technology will be developed someplace but will not be shared. And those are all things. Yes, more social ones. Yes, they are also included. It is really hard to go from one narrative and say what's going on in here and what the risk there is, because we are talking about scaling issues.
Hola, Francisco, muy buena tu plática.
Hello, it was a great presentation, but I have some questions regarding the models. You take SSP5 with 8.5, and you also include financial information. How do you bring these values together? And another question, you take the most pessimistic scenario, but there are other scenarios, because this one sounds pretty catastrophic. All scenarios are there, but to illustrate what may happen with climate change. Not long ago, this was the business as usual scenario. Now we know that the business as usual scenario is something that resembles, and I already feel they are rushing me, but the business as usual scenario is more similar to this one. But we explore all of them. I can send the article to you. And the advantage of these models is that it allows us to look at many other things. What happened with our CP 8.5? What happens with the Paris Agreement? What if we comply or attain the NDCs as they are, or if the United States leave the NDCs, if China leaves the NDCs? These models give you a lot of freedom to see all of those possibilities, because those were questions government, well, with Trump, President Trump was interested in.
Una pregunta dice, can we know how much more Mexico
We-
is reaching early warning and impact risk reduction in agriculture sector?
Pues es una excelente pregunta. La verdad es que
That is an excellent question. We have an issue here. We saw example with the corn, with rice, and this is the first one that's been done at a country level with that detail. It was 50 kilometers by 50 kilometers, very detailed. There was a lot of information missing. And for risk evaluations of what happens in such a place of the state of Tlaxcala, where we have to see adaptation and risk reduction, it cannot be done with a bird's eye view. We need a lot more information. There's a lot of work This is something I like to share with you. We have to look at these interactions and we have to look at these efforts as a constant, as something that needs follow up, because there's a lot of information that you will need, that you know that you need, and it's not off the shelf. You have to produce this information, and this information has to be produced also
Okay,
customized.
la siguiente is, thanks in the research you've conducted, what would you be the necessary phase down rate that Mexico needs to adopt to being able to achieve the target of 1.45 degrees Celsius? And compared with the current trend, what would the consequences be that every day Mexican will see in the short and long term if the same path continues?
Bueno, gracias. La primera cosa es que necesitamos tener políticas
Well, first, we need
digamos,
consistent
no podemos tener
policies.
unas
We
políticas donde
cannot
bajamos
have
emisiones y
policies
otras
that
donde
decrease
estamos
emissions and other policies
comprometiéndonos a
where
tener
we
décadas y
commit
décadas
to
dependientes de
decades and
petróleo.
decades of
Entonces, ese
being
es un
oil
punto. A mí
dependent.
más me preocupa
But I
bastante
am
más
much more
no la parte de
concerned,
emisiones, no tanto la parte de
not
mitigación.
by
Esa nos
mitigation. I
preocupa
am
porque,
concerned with
digamos,
mitigation
puedo estar
because
en las
it can be
negociaciones como
used in
para
negotiations
convencer a
to
otros países
convince
para tener un
other
cierto peso
countries and to
y
have a
lograr
certain weight
mejores
and to
niveles
have
globales
better global
en emisiones, pero a mí lo que
emission
me preocupa
reductions.
mucho es
But
la
I am
parte de
concerned
adaptación
about
y la
adaptation, and
parte
I
de
am
saber
concerned
qué es lo que está
about
pasando.
knowing what's
Eh,
going on.
Tengo memoria como de mosca.
My memory
fruta,
works
¿cuál
as
era
a
la
fruit
segunda pregunta?
fly, the same span as a fruit fly. So the second
Compare with
question.
the current trend, what would be the consequences that every day Mexican will see in the short and long
Bueno,
term?
de las
Well,
consecuencias que vamos
regarding
a ver
consequences,
todos los mexicanos comunes
Mexicans will see
nuestro ingreso va a
is
haber
one, an impact on our income because
va a
GDP
disminuir. No,
will
no les
go
mostré
down. I
las
didn't
gráficas, pero
show the
digamos,
charts, but
mostré, digamos,
I
el valor
show the
presente cuánto
present
perderemos.
value
Pero si
of
ustedes ven
those
cómo va
losses. But
aumentando la
if you
pérdida cada año
see
con cambio climático
the
bajo un escenario donde
increase
no
in
hacemos
those
mucho,
losses in a scenario
es
where
muy
we do
rápido.
little, then this
Entonces,
is very
digamos, a lo
fast.
mejor en esta
So
primera década
maybe
no es
during this
tanto,
first decade, it's not
dependiendo de
so
dónde
much
estén. Por ejemplo, en
depending where you are. For example,
tenemos
in
ya unos
cities,
impactos
we
muy
are
grandes
seeing
y es donde
huge
tenemos,
impacts
digamos, a la mayor parte
where most
de la población.
population is found,
Pero,
but
digamos, ese es uno. Otro, más problemas de salud.
another issue is
Otro, por ejemplo,
more
pérdida de
healthcare issues
biodiversidad.
and
Todas
loss
estas
of
enfermedades
biodiversity. I
superficiales
did
tenemos
not mention it, but we
pérdida
also
de
have
biodiversidad.
studies on loss
Y
of
es
biodiversity,
impresionante.
and it is a
Hace
really
poco
a huge
hicimos un
impact.
estudio
If I don't know if I have time,
sobre
but we
anfibios.
made a
Porque
study on
los
amphibians.
anfibios es como si ustedes agarran y se van a meter a
If
una
you
mina y
go
agarran un
to the
canario y se lo
mine and
llevan y
you
si el
take the
canario,
canary into the mine to
ustedes,
see if there's
¿no?
oxygen, well, amphibians
Entonces,
work like that.
eso pasa con los anfibios, digamos, y tenemos
And
pérdidas
we have
muy
very
importantes
important
en la cantidad de
losses in
especies,
the
¿no? Y
in the
tampoco
number of
hablé de otras
species.
cosas. O
And
sea,
I also
perdón, pero
did
no
not
podemos olvidar.
mention
Estamos hablando
this.
a lo mejor de cosas
It is
dramáticas, como
important.
decía,
We're
¿no?
talking
El
about
RCP
drastic
8.5, que es muy
scenarios like
drástico.
RCP 8.5, which is very
Muchas
drastic.
veces se nos
But
olvida
we
que, no sé si
forget, and I don't know if David has mentioned
pero
this or
hay
not,
lo que
but
se llaman
we
catástrofes
have
climáticas. Y
climate
el problema es que no
catastrophes,
sabemos
and we
cuándo
don't
pueden
know
ocurrir.
when a
Por ejemplo, una
catastrophe can
catástrofe
happen, a
climática es
climate
qué pasa si
catastrophe.
se
What
detiene la
happens
corriente
if
del
the
Golfo,
Gulf
la corriente
Stream
termoalina? Esto es
stops?
lo que lleva, digamos, calor
That
del
brings
Ecuador
heat
a
from the
latitudes
equator
altas,
to
¿no?
higher latitudes.
Ya ha pasado hace muchísimos
It
años, ¿no? O sea,
happened
hace miles de años ha
thousands of
pasado.
years
Sabemos
ago.
que puede pasar, pero no sabemos dónde está, digamos, el
So
threshold.
we don't know. We know
¿Y
that
qué
it can
pasa, por
happen. We don't
ejemplo,
know
con
the
los anfibios?
threshold.
Eso ocurre.
So what happens
Olvídenlo.
if
O sea,
with
básicamente
amphibians, if
México
that
pierde más
happens,
del noventa y
Mexico
tantos
will
por ciento.
lose over
Eso lo que
90%
implica
of
para la biodiversidad
amphibians
y lo
with
que
the
implica también
implications
en
for
economía y todo eso.
biodiversity and then economy and so on.
Muy rápido, se seca más
Mexico
México
will
y la
become
temperatura,
drier
si vieron
and
cómo aumentaba aquí,
temperature
aumenta
will
mucho más
increase a lot
porque hay una
more
redistribución de
because of
calor y una redistribución de
redistribution of
patrones
heat
de
and
precipitación.
precipitation patterns.
No sé si te podamos hacer tal vez una última.
Maybe one last
Em,
question.
¿Nos podrías decir cuáles son los
Could you
gases
tell us about
antropogénicos
the
que han ayudado a
anthropogenic
enfriar el
gases that
planeta
have helped
Ajá.
cool down the
y qué
planet and
actividades
what
los
activities
influyen?
Sí, bueno,
are responsible for
digamos que
them?
más
The most
importantes son los
important are
aerosoles atmosféricos.
atmospheric
Digamos, en los
aerosols.
procesos industriales
Industrial processes
generan
release
micropartículas
microparticles that remain suspended for a short time. They and at the end they deposit, but they have two effects. In a direct effect, they act like micro mirrors reflecting solar energy back into space. In a second effect, they work as nuclei of condensation for clouds, forming more clouds, and depending on the altitude of the clouds, they reflect energy from the sun. So atmospheric aerosols are one of the main anthropogenic factors for cooling down and also deforestation. And just to make you even more worried, what happens when we clean our cities from those little aerosols that can also kill us when we're breathing them? They will also have an effect on warming because you won't have these little mirrors, and then warming will go up. Yes, it was just a cheerful comment at the end of my presentation. Thank you very much.